So here is my week 4 discussion, and here comes the introduction. So in a software architecture, the debate on whether to adopt a thin or thick client approach has been ongoing for decades. Thin client approaches involves placing most of the computing power on the server, while the client provides only an interface. In contrast, the thick client approaches involves keeping a significant portion of computing power on the client side, such that the servers may also use computing power, but the systems cannot rely on servers only. This paper urges in the favor of the thick client approach software architecture, providing examples of present systems, explaining the role of server side and client side programming and the load of the network in such systems. So role of server side and the client side programming in thick client systems. In thick client systems, the client side programming plays a crucial role in handling most of the application logic, while the server side programming is responsible for providing data and the services to the client. Client side applications handles the display of data, presentation, logic, including user interaction and input validation. Examples of thick client systems includes desktop applications, mobile applications, and video games. For instance, the development of the Unity games engine allows game developers to create high-performance games that run on various platforms, including desktop and mobile. Unity allows developers to use C as the client-side programming language, while the server-side programming handles the provision of game data such as user scores and achievements. Thick client approaches in Unity enables developers to create games with immersive graphics, seamless user experience without relying on the server to handle most of the game logics. Load of network in thick client systems. In thick client systems, the load on the network is relatively low as most of the application logic is handled on the client side. The client server communication mainly involves the exchange of data and services, which is minimal compared to the processing power required for most of the application logic. This is in contrast with to thin client systems where the network load is relatively high due to heavy processing power required on the server. For example, the Dropbox cloud storage platform provides a thick client approach on file storage and synchronization. Dropbox client side application handles most of the file synchronization logic, such as detecting changes in files and uploading them to the server. Server side programming in Dropbox handles the storage and retrieval of files. Thick client approach in Dropbox reduces the network load as the client side application handles most of the file synchronization logic and only communicates with the server when necessary. So, in conclusion, the video has urged in favor of this thick client approach to software architecture, providing examples of present systems, explaining the role of server side, client side programming, and the load of network in such systems. Thick client approaches allows for better performance, great flexibility, reduced network load, making it ideal for desktop application, mobile, and video games. So, although thin client systems have their advantages such as better security and easier maintenance, the thick client approach is more sustainable, suitable for applications that require high performance and user experience.